Hi, Shane. It's good to see you, and thank you so much for joining me on the podcast today.
Yeah, nice to meet you, Mate. Happy to be here.
All right, so we got connected through one of your colleagues, I believe. But yeah, I'd love to learn more about you. What's your story?
So I've lived in New York for about 16 years now. I'm originally from Sydney, Australia, where I grew up and was there till you know 2010 or so. And I studied math and finance in Australia, or maths and finance, as we say. Um, and I was at
Why the plural? I've never understood that.
I think it's just the abbreviation for mathematics, right? We cut out the complexity but keep the S.
That is
That's
true
always
because it
been
is,
my
yeah,
assumption.
it is mathematics. That's great. So I think you guys are the correct ones.
I like to think so. Over time, I've adjusted my language to suit either culture, depending on which side of the fence I'm on.
I love it. Okay.
So yeah, I in Sydney, I was actually working for a startup that was in the multivariate testing space, so running experiments. This is in 2005 to 2008. And so experimentation on websites wasn't super common then, but we were working with companies like eBay and American Express to run very large scale digital experiments. And my own role there was bringing experiment design expertise and expertise in something called choice modeling, which is kind of a modeling of user or consumer preferences that they reveal through making choices, and also contributing to the software of metrics. That company was bought by Accenture. So it went from 30-person startup to a 250,000 person global organization that I'd never heard of, to be honest. And it was actually Accenture that kind of brought me to New York. I came to New York to lead up really a delivery team around the metric software that had been bought by Accenture. And so I arrived here and worked with a number of companies across different regions, a lot in financial services, so Amex, JPMC, Royal Bank of Scotland, you name it, delivering large scale experimentation programs to those types of companies, and also teaching them kind of how to set up their own internal expertise to run experiments and to optimize their website based on signals from their audience and metrics that they were looking to optimize.
Take me back to your childhood a little bit more. Were you always into math and science?
Yeah, I would say it's the area I excelled and always enjoyed the most. And so I think when I was finishing high school, I didn't quite know what I wanted to do, but I knew I probably had an advantage if it included some maths in it. And because I didn't really know what to do, I saw this double degree that was paired with finance. So I thought, well, there's a practical way that, that potentially makes money from this thing that I enjoy doing. And so it was actually an experimental degree that was this 4-year double degree that combined mathematical, deep mathematical theory and practice with some programming and tools like MATLAB, and quite a lot of finance as well. So learning things like the Black-Scholes method and other things to do derivative pricing and all those fun things.
It sounds like there's a theme so far through our life around experiments. Got an experimental degree, then went to work on designing experiments for companies. Did you do science experiments as a child? Do you remember some of your first experiments?
Well, I'm gonna say my memory of like childhood isn't as strong as recent years. But yeah, I always had an interest in science and studied things like chemistry with a view to, running experiments. And it was definitely something appealed to me, the scientific method and it has more and more throughout my career that you can learn in a very clear way and also understand behavioral decision making. And so I've kind of enjoyed leaning into this behavioral science, how do people make decisions, and how does the environment affect that, and the choices you put in front of them affect that, and how do we model those decisions mathematically? So those areas have been something that I've continued to come back to throughout my career.
That is a pretty unique view on things because the traditional hardcore math folks are not very much into people or wanting to understand people. And that's why they've chosen that field. Whereas it sounds like you were trying to understand the human side of this. Tell me more about that interest, that combination of interests.
Yeah, I guess I probably skipped one of my jobs prior to the software company Memetrics, which was I looked to go into finance, but I actually hadn't done any sort of internship. I was working at a fruit and vegetable store packing shelves and cutting fruit. And so I wasn't super prepared to go into the world of finance. And I actually landed at a more of like a market and consumer research company. And that's where I actually taught myself choice modeling. And so we would run large scale offline surveys with things like cruise ships, where you would actually put different choices in front of them about, here's a cruise for 5 nights that goes to the South Pacific and costs this much versus this other cruise over here. And based on how people were responding to those prompts, you would start to learn, what are the sort of population-wide preferences and what are the individual preferences. And I was also studying kind of techniques at the time like implicit choice and how people make decisions. So I was very much leaning into that from my first job, even though it hadn't really been part of the degree. It felt like this interesting practical application in the field for how to use some of these skills.
That's fascinating, and I definitely want to get back to that. But I'm curious about your job in the fruit and veggie store. Like, how did you end up there, and how did you know you wanted to do finance? Did you have someone in your family that wanted to do this? Like, how do you go from veggie store to choice my like?
So that was like a late high school, I think, to throughout college. And really, I had a bunch of friends that worked there, and so it was actually working alongside some good mates of mine, who we could sort of do very physical work that didn't require a lot of mental capacity. So, you'd go to university and then come back and put in 8 hours at the fruit and veg store, and it was quite cathartic at the time. And also, I found, and I still think about this, but it was how I broke through a lot of those mathematical problems that I was trying to solve, which you tend to need sometimes like hours or even days to actually ruminate in these problems and figure out a solution. Um, and finance, honestly, it was mostly a pragmatic choice. I didn't necessarily at the time have a deep interest, but I really enjoyed kind of that applied. I think it actually gave me a lot of practical application that's actually served me years later. Like there's concepts, I'm not sure if you're aware of one called like the optimal frontier in sort of choosing a stock portfolio, that I've actually carried through to how you pick optimal scenarios from experiments where you have multiple metrics that you're trading off. And so there's things in that degree that I think resonate beyond the field of finance as well.
But were you seeing some evidence of this in that fruit store where people were making choices? You're looking at them like there's got to be a better way we can price some of these products or do the assortment is just bothering you so much you decided to study it officially?
I mean, it's possible. I don't know if you've heard, there are like optimal designs for grocery stores that have been deeply studied, where, they guide you through a certain path that maximizes the total size of basket. Possibly, I've never thought of it that way, but now I probably will have to give it some deep thought as to whether that affected my choices through life.
Yeah, I think there's some version of path dependence to where we end up in our
Mhm.
careers. We also tend to very heavily discount these early experiences, which in some ways it's counterintuitive because you all understand the importance. Like if we have kids, you place a big emphasis on raising them properly and making all these choices, and like they don't even think about these first jobs that, in retrospect, probably played a big role on just how you think about the world. I think about the professional environment. So I'm always curious to see how people end up in the careers that they ended up in. And to your point, it's like it's not even just like this is, oh, it's like a interesting first job, but these are entire like massive industries that now spend a
Hmm.
lot of time, money, and data analyzing exactly these kinds of problems. It's yeah, it's interesting to see. That's where you got your start. The so okay, so tell me more about choices and how, and maybe even a high level framework of how to think about making choices. And it sounds like the from what you're describing, a lot of it is experimentation where you're trying a bunch of A/B testing on these different choice frameworks. But are you coming at this with some hypotheses as to what works, what doesn't work? Like, what are some of the rules of thumb from someone trying
Yeah,
to figure out how to price their services or what choices to offer for their services?
yeah. So I feel like that, through the time at Memetrics and then onto Accenture, we had a very sort of strong discipline around how we would design these experiments for maximum effect. And I think what you find when people, and I actually carried that on to, then I went to the New York Times for almost a decade. And I think part of what I was able to bring to that job was an experimentation culture that we used across product marketing and even areas of editorial. But uh, I think a lot of the time when people get an experiment canvas, they think about, all right, what are the easy things that we can test? And there's even famous examples like the Google testing 30 shades of blue, which to be honest, I think is kind of a garbage test that's driven towards getting spurious results from just because you're feeding so much in without any strong hypotheses. And so the way I would do it and would basically hold workshops with these customers, in various industries, but financial services was probably the most prominent one. And we would look at their experience that they were designing on a website or an app and basically come up with a series of hypotheses that tied back to the consumer behavior that you were trying to drive. So ideally, like take them away from the current experience and come up with their expert hypotheses, whether they are designers or marketers or product managers, and then typically translate those hypotheses. Maybe you come up with five hypotheses into the underlying attributes and variations that you might want to test. And what we were actually doing then was tending to run these large multivariate experiments. So you'd have, an attribute related to your pricing, and you might have an attribute related to your benefits messaging of a certain product. And it was really tending to break down kind of the science of marketing or product experiences and then actually model out how those preferences, for price and preferences, which were the important decisions for a customer, and then how do they interact? And so then we'd model that out both as a population level and then for individual segments to see if you could actually optimize it for different cohorts of users. And so that was kind of the process, go from workshop and hypotheses and then come back with a series of findings that made you smarter about the business and how the business works and not just optimizes the color of a button.
What are some examples of these types of experiments, and are there any that surprised you?
Yeah, so maybe some examples. My sort of era after that at the New York Times, I was deeply involved in how we experimented with the subscription paywall, which, this was a time of transformation from the Times from an advertising business to a subscription business and a print business to a digital business. And so we were thinking about, really how to maximize the effectiveness of that subscription paywall while also continuing to build habits amongst a large, and diverse news reading audience that you want to attract. And so you don't want to put these very blunt tools on it and just sort of drive everyone to subscribe. You actually need to think about how you build engagement and habits. And so those were some really interesting experiments, as well as experimenting with things like the homepage of a media organization, because you have so many things that you're trying to achieve with a homepage. And those were always the most challenging experiments because you might have many stakeholders to a homepage who have different competing objectives and you can't achieve them all at once. It's usually something of a zero-sum game at the end of the day. So, you have to kind of upfront align executives on what are the important objectives and how that translates into metrics that you'll actually optimize the experience to. Probably one of the most surprising that I recall was actually working for a company, a Chinese e-commerce company, and I think we had learned a lot from working with American e-commerce companies that simpler design and clearing out the page, it was almost like the Google search design. Like, let's have as few things as possible and really aim them towards this single purchase experience. And the Chinese e-commerce website, or at least the one we were working with, was very different. It was much more like a market that you might go to where you have all sorts of shelves that you can look at that have very different types of products. And so I remember trying to, test a bunch of hypotheses around simplifying that experience to drive more effective checkout, and it actually did very much the opposite. And so it was an interesting kind of view into the different populations and cultures and what they respond to from a treatments perspective.
Do you have any sort of hypothesis as to why that's the case? Why one culture prefers simplicity and another one prefers complexity?
I mean, I probably just that I think the trend at the time in American websites, and maybe this has even gone in the other direction since then, but was very simple. And I think, then the environment of websites you're dealing with follow a similar simple structure. And, I recall probably like 10 to 15 years ago when everyone just switched to the hamburger menu. And so it becomes easier for you to navigate similar websites because you have that same design construct. And so I think there's probably these environmental conditions that make you better at navigating certain types of website than others, I guess.
Yeah, that's a fascinating concept. I've heard of those differences before, and I'm just thinking about the early internet days where all the even the Western world, the pages were much more crowded, and that was partly as a response to the fact that there weren't that many pages, and it was easy to create these
Right.
lists of here are all the websites of you should go to, and then and I also feel like I don't know, I wonder if there's something around. I've heard minimalism be described as something relatively elite because you to do away with things presupposes that you've already had so much abundance that you now need to like clear your mind and you have like the luxury of being able to clear your mind and your house, whatever it is. Whereas in other societies that are more developing, it's like, no, like we still need stuff. And like the way that you display your success and wealth is through an accumulation of a bunch of things. But it is fascinating how these other sociological elements are playing into design and the outcomes for these kinds of sites. But I wanted to go back to the point you had made about the New York Times subscription. And if I heard you correctly, you're saying that there are certain things that you can do to get a lot of subscribers, but you might not want to do that. And I was wondering why. Like, is that because you can increase churn? And again, it could be like an easy thing, or you can trick a bunch of people into signing up, but then they won't stick around. Like that sounds a little bit counterintuitive. So I was wondering if you can expand on that.
Yeah, I think there's a few things. One is that, organizations like the Times are looking to achieve wide reach on their articles, and the Times will say itself its strategy is to be a destination for many, not just subscribers, but to be a destination. And so there are news websites that will lock everything down to the point where you can't actually read until you've subscribed, right? But that actually cuts you off from potential future readers, from readers that maybe aren't ready to subscribe because they haven't experienced enough of the breadth and the depth of the coverage. And so we had done a lot of data science that really showed that, reading broadly across the times is correlated, and I think it often points to causally related with subscribing and retaining. And I think you've seen this with companies like Spotify too. They know that their longest, sort of their highest LTV or their longest running subscribers actually listen broadly across different genres. So I think you see this with a lot of subscription products. If you're coming there for one, piece of content, and that actually, maybe it's one column that occurs week after week, and you come and read that, maybe potentially over time you'll tire, and then you'll actually churn from that subscription service. And so we knew inherently that people need to experience this, and really we were aiming to build sort of regular weekly but healthy habits with a large audience, a large and engaged audience. And so you need to then actually tune this paywall so that you're able to siphon off the people that are ready to subscribe and will retain long term, but you also allow other people to still build a habit with the product and experience the depth and breadth of it.
How did you think about that funnel and the amount of data that you had on these individuals as you're looking at their readership? Like, is it because I imagine if they're not, if they're logged in, even if they're on a free plan, you can then track that much more easily. But if they're just coming on the site and you have some cookies on their browser, and you can still get some visibility into their behavior, is that like was that enough to be able to track them on an ongoing basis over like longer periods of time, or was you, I guess what was the sample size or the population rather that you're like working off of to make these experiments?
Yeah, I mean, at the top of the funnel, you're dealing with, potentially hundreds of millions of users or visitors a month. But as you point out, many of those are anonymous to you. They're a cookie that appears once or maybe twice on a desktop browser or on a phone browser. And especially with the proliferation of devices, you see that when you can actually look at logged in users, they're actually covering many of those cookies and across many devices and many browsers. But yeah, at the top of the funnel, you had this very large audience, which could come into the places like the Times through news or could come through other avenues. And then the Times also had a strategy of really investing in a registered and logged in audience as kind of the next step in the funnel. And I think that was critical because that allows you to actually understand these readers across devices. It allows you to give a consistent experience across those and give them consistent advertising experience as well. And it allows you to actually use that deeply engaged and logged in pool as kind of your strongest audience for subscription. So that, you see amongst media companies a huge investment in things like newsletters that can drive that sort of registered and logged in behavior as well.
And did you see a similar pattern in terms of the audience moving down this funnel from the logged in perspective? If they're reading broadly, then they're more likely to then pay. But was there a similar trend where even before they create a free account, that the more they browse the entirety of the site, the more likely they are to create an account? Or are there other trends in the beginning that would get people? They also see an argument to be like, I'm trying to read this article, I can't see it because it's behind this thing. But if I sign up for free, I get access to it. So maybe I'm not like a wide reader, but I might still be incentivized to sign up just because it's somewhat of a low
Yeah.
cost. So I'm curious how what these if the behavior, the user behavior to go from different stages in the funnel is actually pretty different.
It's taking me back a while now, but there were certainly things that we looked at in terms of, certain types of coverage that you could actually drive high registration from because there's a strong willingness to read, as you point out. And then if you actually enable registration there, you can actually build up a registered audience. So that was certainly a point of study, which was like how do you actually maximize that point of registration? But also, there were parts of the journalism where you actually don't want, when we're talking about something like COVID coverage, there was a journalistic imperative for everyone to see that nationwide, right? And even worldwide. And so there's an organization like the Times, there's always this trade-off between what is the business imperative and but also what's the mission of the Times and how do we achieve the biggest reach for these critical stories. But I would say the thread throughout, both to subscription and retention, is kind of frequency of reading, depth of reading, and breadth of reading. And I think that's very common across media organizations that are selling subscription products.
I was just going to ask about the churn piece of it. So you're saying that it stays pretty consistent in terms of the metrics you guys were tracking. What are some of the indications of someone's very likely to churn?
Yeah, I think the same sort of signals, but then obviously a subscriber is reading far, far deeper than a non-subscriber, right? So you have to tune what's the point at which you become a churn risk. But I'm probably, having been out of the Times for about 4 years, I'm not sure I could speak to the state of the art there now on how they predict churn.
And yeah, going back to pricing, how I mean, it is obviously a very, very common question, whether it's New York Times or elsewhere. Like they're constantly experimenting with like freemium plans. You're experimenting with, and even like we just had our conversation at System2 right before this in our sales meeting about how we do our pricing. And for us, it's different. It's like B2B contracts. You can't run experiments. You don't have that many like clients, that we can say, hey, we're going to A/B test these things, and
Sure.
so it's you're relying a lot more on like gut or theory than actual experimentation. Yes, you have some examples of what's worked and what hasn't in the past, but it's more anecdotal. So yeah, I'm curious, like, yeah, what how you're thinking about these kinds of pricing problems or just like overall rules of thumb, and then maybe start with a business like ours, like where you don't have the luxury of doing like large A/B testing. How would you solve that kind of?
Yeah, it's a good question. And I would say, like, Monte Carlo is a similar size, a B2B company where we have to make pricing decisions off of some experimentation, but ultimately you have to make a call at the end of the day about your pricing model and about your price points. And so, I've always believed in doing some qualitative research and often as informative to a larger scale experiment, right? Which is how I thought of it at places like the Times and at places that I was working with when at Accenture, which is, where we can, let's feed in strong qualitative research, customer interviews, or whatever competitive research we can to understand the right pricing, and then let's run an experiment with some, and I would often try to really test extremes, like how far are you willing to go across these different type of pricing attributes, whether it's the type of plan versus the actual price points that you could test. Because analytically, you can always kind of interpolate in the middle, right? And draw the line and understand maybe what demand will look like between these two price points. So you need to really know those extremes. I think when you're getting to like a smaller B2B context, you often have to start with those extremes again, but then maybe look at some early indications from, two cohorts that maybe you're rolling out sequentially as opposed to simultaneously, but then you're able to look at some early indicators that those pricing plans are working. Because you probably also, and I can say this from, say, Monte Carlo, you're not going to wait a year or two to see the implications of your experiment. You really want to move fast and make a decision within weeks or at most months, and right. And so you're looking for early signals that you can that pricing model is actually going to work for your customer base. So we probably just lean more on that qualitative feedback that the pricing plan's resonating, and also some evidence that it's achieving the goals that we set out to achieve.
Makes sense. So tell me more about Monte Carlo and what you're doing there now.
Yeah, so Monte Carlo, in case you don't know, Monte Carlo is kind of the leading data and AI observability company. And so my role at Monte Carlo is effectively I've had a few different roles since I've been here, but my latest role, which I've been in for the past couple of months, is leading our research and product strategy around data and AI observability. So that's really considering how we extend our capabilities into this new world of data teams building AI applications. And so just in this role, I've been talking to dozens of both Monte Carlo customers and non-customers about how they're using AI for various means. Some of them could be to increase productivity within their teams. Some of them could be kind of how they're getting their data estate ready to support artificial intelligence applications. And others, it's they're actually building AI applications for various use cases, and thinking about how they can be reliable and trustworthy.
What does data observability mean?
Yeah, good question. Maybe I should have started there. So, data observability is really founded on this premise that data products, and you can think of that as business intelligence products, machine learning applications, and now AI applications, they're becoming more as or more important as the apps that are built by software engineers. And yet, data teams haven't really had historically the tools and processes to make them reliable and make them sufficiently high quality that they're kind of fit for prime time. And I think in the last decade, you've seen data teams, really hit the forefront of the organization where they're building both internal applications and external applications that rely on data to have that sort of five nines of reliability, be deadly accurate, right? If it's a financial data product, and have a great user experience around it. And so the mission of Monte Carlo, if you think of these data and AI products, is to reduce what we call the data downtime so that those data and AI products can be more heavily adopted. I tend to think of that data downtime equation as being the time to detect an incident plus the time to resolve an incident multiplied by the number of incidents. And so that's a classic downtime equation. Those are the things that will cause you to have data downtime, AI downtime, application downtime. And so the Monte Carlo platform, and in fact, any observability platform then, is solving for your ability to quickly detect any incidents in the complexity of your data estate and data environment, to be able to triage and resolve and troubleshoot those incidents so you reduce that time to resolution, and then be able to measure the progress you're making and point towards where you can make improvements so you reduce those incidents altogether.
What are some examples of common incidents?
Yeah, so um, maybe I'll sort of start across the data and AI estate. Often, what we think of, and I think where Monte Carlo has kind of, I'd say, revolutionized this thinking, is that historically data quality was managed at this kind of endpoint. Is the data I have on my screen, you know, high quality? How do I measure that, and how do I report back that this is high quality data? And the issue with that is that you're essentially looking at a silo. And that could be a model, that could be an AI model that you're looking at the output on, and you're saying that that output is hallucinating or it's low quality, or it can be a dashboard, for example. And so the way Monte Carlo thinks about this is across, can I look at the data estate across data, systems, code, and model? And any one of those can be contributors to a potential data incident. And so an example would be something like the source data quality, the classic kind of garbage in. And this can be software engineers maybe changing the code implementation of their product. It starts emitting some different data. It could be a finance company that you're buying market data from, right? That has an outage or has some issue with a change in the schema. And in AI products, it can be unstructured data. So I've talked to customers recently who are building these kind of complex end-to-end chatbots, and at the front of the pipeline, they're feeding in a knowledge base, and then they might find at the end of the line that the responses from this chatbot are actually unreliable because the knowledge base is out of date or it's incomplete. And so there's various forms of this kind of garbage in data quality that can contribute. I think secondly, you have then the kind of transformation of this data, which could be using something like DBT to transform traditional data models and to be able to report out. But in the case of an AI product, very often you're building in context in the form of what's called embeddings. And so you can find that drift in context over time can affect the reliability of the AI product. A couple of others that I'll just quickly list off: sensitivity to code changes. Talk to a number of teams where the LLM provider might upgrade from 3.5 to 4.0, and suddenly you have to completely retrain your model. But you can also have various forms of orchestration and other code changes and system complexities that contribute similar issues. And then at the end of the pipeline, you have model evaluation, which very often, as I talk to teams, they're still handling, especially with these AI products, the type of evaluation predominantly with humans, evaluating the kind of model outputs.
And you mentioned the role of data teams. I'm curious if you feel like that has exacerbated this issue, but is the point that you're making that data teams are now at the forefront of the organization, but they're not classically trained in computer science, if you will, and so they don't have all these good, like behaviors drilled into them because they tend to be much more scrappy, solving problems quickly, and that can open things up to these types of issues that you just described, especially when you're dealing with like data at scale and these like very large systems that are built by a bunch of people like me who don't really know how to code, but somehow have managed to get in front of the business people more so than the actual like tech folks.
So I think about it in a couple of ways. One, the data engineers often sat in the middle between software engineers and say data scientists or analysts. And you do have, to your point, a lot more data analysts and data scientists, building code that's maybe fit for purpose at a point in time, but isn't built to be reliable. And then I think the classic problem in many data teams is that you have data engineers that don't have a lot of context of the downstream use cases, but they also don't have a lot of context to the software engineering upstream of them. And you go back further, and the software engineers don't don't know any of the ways sometimes that the data is being used downstream. And so I think in the world we've seen of the past 10 years, the data has become way more important to the business, both to make decisions and to build products, machine learning products and data products from. But you often have many points of failure in there that could be the software engineers, it could be the transformation that the data engineers are doing, and it could be these complex pipelines that data scientists and analysts are building. And now I think with AI, you're seeing a bit of a different problem where data is at the head of the pipeline to building these AI products, right? And people are building AI products and demoing them and they look great, but then when they go to put them into production, they realize that a lot of the data is not yet reliable or ready for prime time. And so the software is now being built, and in order to make those reliable and iterate on those AI products, you need to be iterating on the data and making it higher and higher quality.
And it sounds like this is what Monte Carlo, what you guys are solving through software. But before we get to that, I'm curious if you have thoughts on how to mitigate some of these problems through organizational structure. Like if you're to start a team from scratch, you don't have any of these like legacy departments, how would you do that to make these types of new like AI applications function properly?
Yeah, I think that's a great question. I think fragmentation across teams is often the silent killer here, and lack and unclear accountability throughout this like data value chain. And so I think you see the more handoffs that happen, the less clear the ownership is when an incident occurs, and the harder it is to actually resolve these incidents properly and prevent them happening again. And I've experienced that firsthand where a complex data incident that goes across 3 to 4 different systems could take like a week to 2 weeks to resolve. And then it may well occur a week later in the same way, and you haven't yet prevented it. I think in terms of solution, I typically ascribe to the philosophy of you built it, you own it. And I think especially when you think about machine learning and AI teams, building these, effectively full stack teams that own as much as they can. I think in very large organizations, it's often impractical, but in mid-sized organizations, you can design around data products and you can have teams owning one or two data products that are what they provide. And then you can have clear sort of accountability between interdependent data products. But I think as we're seeing more of these AI teams built out, the best model I'm seeing is that you kind of have a product and software team, but you have the machine learning expertise built into that, and you have the data engineering expertise built into that, and the data science, so that you can both provide high quality, well governed, secure, and private data to these applications. But then you also have the expertise of, say, the data scientists who can evaluate the quality of the output from these applications in a way that I think most classical software engineers aren't ready to do.
Isn't that asking a lot of one individual, right? So yeah, like ideally, one person would be able to do a lot of these things, or at least be aware of a lot of these things that they have good opinions or create some good structure around it. Or I guess I don't know, to ask that differently, do you think from an educational standpoint there are degrees out there that solve this right now? Because I mean we just started getting data science degrees, but your point is like it's not enough to really understand like what would be the ideal training so that these folks can have the right skill set to create the team they were describing.
I mean, it's a good question. I'd be interested in your perspective on it. Like I think what's always going to be relevant is what data scientists learn about statistics and the application of statistics. And I think under the hood, we're just seeing so much change so rapidly about how pipelines are engineered. And so I think for anyone working in data, having a deep understanding of statistics and mathematics is critical these days and will be critical for the future. I do think, and I saw this over my tenure at the Times, but you know, we went much more towards having a very technical skill set on the analytics and data science. And like the data scientists were machine learning engineers, the analysts were effectively analytics engineers, and everyone had to be held to a fairly high standard about how they could build pipelines and contribute to this. And I think that needs to get stronger, it feels like more in the discipline you set up your data team than in the education itself.
Yeah. Look, I agree. And the way that we've been trying to solve this problem here is by having our folks do as much as possible from beginning to end. To your point about accountability, like if you're responsible for you need to deliver this to a client, and yes, you have other people on the team that can help, but then they know it's just you who's going to be held accountable. They're going to have to figure out everything from like data engineering, even for us, it's how do you source the data sets to answer a particular problem, dealing with compliance, pricing negotiations, like all the things that these are and we do have like separate folks and departments that specialize in that, but at the same time it is on that one person who is ultimately accountable for getting that project done. And we also encourage and train them in how to do this stuff themselves. And so sometimes it's a lot easier for you to do it than to wait for one of the specialists to like chime in and get stuff done. But at the same time definitely see the issues that you guys in Monte Carlo are looking to solve, which is that yes, we have like one person do as much as possible, but that does lead to things that are not always like sustainable at scale. It might be okay to get this one thing done, but then yeah, you do end up with issues down the road.
Yeah, and maybe I'll just caveat when I say you built it, you own it, I typically don't mean an individual, I mean a team. And so that was also an anti-pattern I've tried to avoid in the past is having individual ownership of something, whether that's a machine learning product or a data pipeline, because when that person goes on vacation or leaves the company, then someone's likely rebuilding that. And so when I talk about you built it, you own it, I typically talk about teams and teams that are designed around modular products that they can own, as opposed to kind of, I think, what's traditionally been kind of horizontally defined teams where they own ingestion or they own transformation or they own business intelligence. Like, I just don't think that really works anymore for most organizations.
And how are you guys solving that problem through your products?
Yeah, so Monte Carlo, if I come back to really what Monte Carlo enables, it enables you to detect incidents, resolve them, and measure over time and sort of put in place the operational measurement around data quality and data incidents. And so detection is something that we've really looked at from the extent of historically teams were defining a lot of manual rules around data and usually failing to cover the extent of what you need. Like we've talked to teams that might have 60,000 tests defined and still aren't covering the potential problems that can happen. So Monte Carlo started by really applying more classical machine learning to that problem and learning the freshness of every data pipeline based on the metadata, the volumes of data that are traveling, and then down to the specific fields and the quality of those fields. So you can look at the distribution over time and the percentage nulls, and then really automate as much as possible so that you can scale out monitoring across that data product and identify any issues that are anomalous. And then what we've been doing lately is actually add to that what's called the monitoring agent. And so this is us using artificial intelligence to help with that expanded coverage of your data estate. So the monitoring agent then will actually look at your data, look at the metadata, and look at the lineage to understand how it's used and actually suggest ways to improve the coverage of your data. So it's kind of mimicking what a data steward or a domain expert might do. And so just an example we had was working with an MLB team who had like a table of pitches and it could look at multiple columns and essentially say a fastball needs to be between 1,500 and 3,000 revs per minute or something like that. I'm not sure if I've got the RPMs right, but
I wouldn't know.
suggest
Sounds good.
suggest those sort of domain specific rules. And so that's really our approach to monitoring is both human defined automated monitors and now this monitoring agent. And then I think the next step is when you have an incident, how do you minimize that time to resolve the incident? And so there we've invested in, and we're releasing in the next couple of months, what we're calling the troubleshooting agent. And the troubleshooting agent, which is super cool, actually looks at the context from an incident, looks at all those things like samples of data and lineage, and then actually spawns a series of sub-agents that go and explore, is it a GitHub PR that may have contributed to the incident? Is it a transformation change using one of your ETL tools? Or is it an issue that's introduced in the underlying data? And it does that across all the upstream tables and then comes back and produces a summary and some recommendations about how to fix it. And so that's the latest in terms of how we're, adding to our lineage capabilities and our root cause capabilities to help data teams essentially use AI to massively expedite the speed at which they can resolve an incident.
How are you thinking when you're building your products about this delineation between what you're using AI or agents to do versus what you're writing in software, and how much? Because I mean, historically, I'm sure it was mostly, if not entirely, all software, and now you're talking about all these like agentic tools that can do all these things at much larger scales. Do you feel like at some point we're gonna? I mean, it sounds like part of the argument, right, is that you do need software to do things that software is good at, and you need the agents to do the things that they're good at. And if you're doing just one or the other, you are definitely falling. And if you're just in the software world, you're falling behind. And if you're just doing like pure AI without any sort of like orchestration or architecture on top of it, you're also just creating a mess because these things seem to work, but there's no real like sustainable structure. And yeah, so I'm curious like how that is shifting that line between software and AI is
Mm.
shifting in how you guys are building your tools.
Yeah. And I mean, just as an aside, I find myself using the word humans more than I ever have lately. It's suddenly become very common in vocabulary to talk about humans in this very abstract
It's like we
sense.
have to start justifying our jobs. Like human, why am I paying you so much when I can have a million agents instead?
Yeah. So we have an R&D team set up that's really focused on exploring these kind of AI and agentic capabilities. Well, most of the rest of our engineering squads are focused on very kind of traditional software capabilities like, building integrations or building the right user experience for our product. The R&D team though has been exploring what are the long run solutions that people need or the problems that people have? And I think this is this is where, everyone's often jumping in and saying we can build a chatbot, right? And it probably too often. And I think in talking to data teams, the ones that are having more success are often they might be doing intelligent document processing with AI, right? Or building some discovery interface that's somewhat AI related. I think there is a critical thing to nail down the problem that will actually benefit from AI. And often that is a problem that you've tackled with humans enough times that you have a pattern that you know. And so troubleshooting is one that's a very human driven activity today, right? And there's a pattern of what engineers do. So understanding the user here is really critical. But engineers will go and one by one test a lot of different hypotheses about what could have caused that data incident. And so really what we're doing is trying to kind of supercharge that engineer and help them do much more of that work in parallel as opposed to sequentially. And so I do think it is where I'm seeing the successes, it's where there's a process that's really well understood and potentially documented over time. I talked to one of my fintech customers who said they just have enough data from doing this as a team that there's enough to learn from where they can actually get a product up and running with an LLM. And so I think it's much more these kind of heavy human driven processes than necessarily replacing traditional software engineering.
What do you think the end state is, or just even fast forward a couple of years here? Because it sounds like using tools like yours, you'll be able to like much more easily identify what's going wrong, detect these incidents from happening. So 5 years from now, we're not going to have this conversation anymore because like your system is up and running on every whatever on every AI app, and all these things are being optimized as much as possible. Like we're reducing downtime, identifying things as fast as possible. Or do you think, just in terms of how complexity theory works, I guess like you guys are advancing, but at the same time, like the terribleness of code and apps and things that are going to come out of this proliferation of AI is going to be grown at like an order of magnitude faster than you guys being able to fix it.
Well, that I think that's a good point because I think like what Monte Carlo benefited from in the early years was data teams had consolidated around what a good stack looked like, what a good warehouse setup looked like, and what are the tools. And so you can then build a product around that. And I think even with the foray into AI, now you've got double the number of orchestration tools, and you've got vector databases that you have to monitor and embeddings within those vector databases. And so there's additional complexity. And I think now, you've got people talking about these multi-agent systems, right, where you have to, which are not very observable today, right? You're actually going to have a situation where you're able to observe the decisions that one agent is making and how they're communicating with other agents. So I think you're pointing at the problem that, we keep actually seeing more complexity built into the type of software that's being built. And I think everyone's talking about the fact that you're going from deterministic outcomes to probabilistic outcomes. And that's a real shift in engineering. I think machine learning has been the biggest sort of precursor to that, where you have these models that are acting in a non-deterministic way. But I think that's going to be much more of the environment that we're monitoring, and it does feel like a very challenging problem to meet.
It's an interesting way to put it about the probabilistic nature of this, and it's kind of like quantum computing, but it's already here in a different kind of domain. But yeah, you run the same piece of code, and with software, you'll get the same answer all the time usually. But with this, it's like yeah, who knows what's going to happen, and you have to design like your whole like architecture around those kinds of issues.
Yeah, I mean, I've talked to teams who are running their LLMs multiple times to see if it repeats the same answer as a way to see that it's accurate and reliable, right? Because if it's changing its answer, it means that it needs more context potentially, or it doesn't necessarily know, and it has things that are similar probabilities.
Yeah, but at the same time, is that a bug or is that a feature? You would want reasoning, just like with humans, you want to update your hypotheses as new data comes in, and you ask the same human the same question twice. I mean, look at politicians, right? Like it's a feature in that line of work to change your mind all the time. So yeah, I'm curious, but it would require a very different mindset on and our assumptions on what is, yeah, like you have these like non-stationary results from things that you expect it to be extremely stationary.
Yeah, I think it depends on the application, right? If it's a fundamentally creative application that has some bounds to change its mind, or if it needs to be closer to a deterministic system. And a lot of finance teams I've talked to are still, this set of problems needs to use traditional modeling techniques because we need much more certainty in the response. And I also think it comes down to the expectations you set with the user of the product. Do they expect that this thing is answering the same thing every time, or do they expect some variability?
Now, take us back to your role in Monte Carlo. So you said you're leading research. Now that I understand more about what it is that you guys do, yeah, it'll be interesting to see. It sounds like, yeah, you are working on the more cutting edge part of what's going on, and I'm curious to learn more about it.
Yeah, so basically over the past couple of months, I've been mostly doing primary research, and I have a counterpart in engineering who's doing more of the, deep technical research behind these methods. But I've been really focused on talking to data teams about what are the applications they're building, what is the role of the data team in building these applications? Because sometimes they are offering talent, sometimes they're offering platform, and sometimes they're owning the solutions themselves. And so that's ranged from teams that are building chatbots, both internal for their organizations and customer facing, and as I mentioned, some teams that are building intelligent document processing, methods of personalization, and then some sort of more basic kind of summarization applications, right? Taking a lot of call volume or interface with customers and actually summarizing for various purposes. And so I'm talking to those teams about what they're building, how they're using Monte Carlo today within that pipeline. And often these are RAG-based applications. So they're bringing in context, both structured and unstructured, from the data environment to inform the actual response that the LLMs are giving. And so an example there is a customer like Intuit Credit Karma, who built a financial advisor bot, and they need to have that rely on credit data that's highly reliable and accurate to specific users. And then what are those teams doing to solve for that end-to-end reliability? And as I kind of mentioned earlier, a lot of what they're doing today is human evaluation, but what we're, building with Monte Carlo and what we support today, we support a lot of the structured and unstructured data, and we're doing more to invest in that component. We support some parts of the architecture, and we're investing more in how we can support that architecture, vector databases and orchestrators that teams are using, and then model evaluation. So whether they put the data back into Databricks or Snowflake, how do they evaluate continuously the model outputs and ensure they're, reaching the right levels of precision and recall and reliability?
It's an interesting position for you to be in because you get to look under the hood at a lot of these companies and how they're actually using AI. I have friends that, for example, have started an AI investment fund and trying to find companies that are doing this. One of the challenges they run into is like everyone is now saying they're an AI company, and then you peek under the hood even a little bit and you realize it's nothing, just like another whatever, just integration.
People pulling.
Yeah, or just like using ChatGPT and then saying this is, yeah, we're AI now. And so I'm curious, have you seen a wide range of sophistication across the folks that you're speaking with? And are some of them like significantly farther along than others? Like what have you seen? What are some of the scary stories you've seen when you looked under the hood? without naming names.
I mean, there's definitely a spectrum of where teams are, and I think a lot of the times, especially in large organizations where there's potentially more red tape to actually build these things and put them in production, you have a lot more focus there on AI readiness. How do we manage our data in such a way, especially when you're a data team that's supporting 10, 20 business domains potentially in a large enterprise, they're very focused more on how they can prepare their data to be ready for the inevitable wave of AI products that are being built. I think where I've seen the most kind of early movers is the kind of technology forward companies that are that mid-size that, have the teams that have already been building often machine learning products, and so they have the expertise internally that, they were a machine learning expert and engineer, and now they're machine learning and AI, right? And they're actually the internal experts both around the platform they need to build these, but also how they measure quality of them and that sort of thing. Uh, I'm trying to recall if there's any horror stories I can bring to mind. I don't think so much. I think sometimes what I encounter is probably a range of how they're thinking about it organizationally, whether it's all a bunch of disparate initiatives across the company, right? The data team is maybe not exposed to all the ways that their data is being used in these applications. Probably those teams building the applications don't actually know how reliable that data is that they're building with. So that's probably the one that people sometimes raise up to me as, I think we're not really organized around this. But, in just as many or more companies, there is really alignment on an initiative to go and invest in this across the data team and the technology team.
And you were saying that once there is this alignment on investing in it, that the larger organizations are, because of the red tape, they're not able to act as quickly on it. So they're working more on the fundamentals of getting the data cleaned up, organized, etc., to prepare them for when they can start executing on it, versus the smaller companies are able to just jump in and try to solve these problems as they arise.
Yeah, that's a generalization, but that's definitely what I've seen across, 30 to 40 companies is, if you have a data organization, especially one that's already building data products, they've been able to jump into this mix and get things out the door. And what I was surprised when I started the research was how many teams had AI in production. Often I will say those are internal use cases, and I think it's much easier to get like a demo up and running than get something actually into customer facing use. That's been a barrier, and often it's because you're somewhat limited by human in the loop or human evaluation on these solutions. But yeah, I've been impressed and almost surprised by like how many data teams have sort of worked around this and figured out the team that's going against it and actually started to launch some products in production. But I do think, to maybe to your question, like the larger organizations, as a result of being larger, there's less direct connection with the downstream users of the data. And so there's often some distance between the data team and the actual business domain that's maybe trying to build the end application.
Who, if who do you think would win between these large organizations and small organizations? And I've been going both ways on this because on one hand, it would sound like, yeah, like if you're the smaller, you're more nimble, you can execute faster on new technology, and that's been historically true. And then you've seen the opposite argument happening now that it's actually the larger firms that have an advantage when it comes to AI because they have access to more compute power, more data, all the things. And so, and I'm curious, even for your organizations that are not necessarily all tech companies, whether if you're large, there's a benefit in waiting because the models keep getting better and better all the time, and the architecture you would be building on a model now, like even honestly, even if there's like data cleanup, I feel like if you just waited a little bit, like now we've been doing data tagging for credit card data, for example, for a long time, and we know people that started companies doing this, like a few 5, 10 years ago. And it was a lot of work, and now it's like we're just getting this for free out of these LLMs. And so it benefited us not to have invested a ton of like capex into these types of systems because now this new stuff is free. So I can see that argument with these like larger firms, like, hey, we'll wait this out and it's going to be so much easier in the future instead of us trying to do this. But then I can also see the opposite, which is like, no, you got to start playing around with these things, and that's how you learn how to do it. And if you don't, you're going to be left behind.
Yeah, I mean, I think I have a similar view to maybe what you've just presented, which there is a tax to being an early mover on this, in that a lot of the teams that are building things are having to go through multiple cycles of rebuilding it, and often the investment is not met by the return from these products today. There's a number of teams I've spoken to that launch some sort of discovery or chatbot type feature in their product, and when you ask about the ROI of them, it's kind of middling, right? It's, yeah, it's more about the learning and the organizational speed of getting it up and running than it was about necessarily the impact of the feature. So I don't think we've yet seen like really true return from these, especially the customer facing. I have seen return from some of these internal data products that are about curating data and actually, moving, sort of making more efficient processes internally. At the same time, I do think you're not really going to establish AI ready data until you start building. And some foray into that, even if it's just like building summarization tools, I think is necessary for your organization to kind of learn the working models of this and have a chance at actually competing in this space. So like I kind of think AI ready data is actually building a product that requires your data to be reliable.
Yeah. I mean, it reminds me of a story from Warren Buffett where the punchline is that efficiency is overrated. And the story is that after he bought the textile company, a worker from the factory comes to him saying, hey, I've got great news. There's a new piece of equipment that's going to make us like 50% more productive. And Warren famously replies like, gee, I hope it doesn't work, because if it doesn't, I'm going to have to sell the whole company. And the point that he was getting at was that yes, everyone wants to buy efficiency, but what people don't take into account is the cost of that. So you have to spend a lot of capex money to buy this new piece of equipment. And once you do, and this is the critical point, is that okay, fine, you achieve that efficiency. But then are you able to capture those benefits, or do those
Hmm.
benefits end up just getting washed out to your customer? And so the point there is like, what's to stop a competing factory from also putting in this same piece of equipment? And now both of you spend tons of money on the equipment, and you're now both going to have to lower your prices because you're competing on price for the customer. So the customer is going to get a vastly cheaper product, but you just spend a ton of money on the systems. I think something similar is happening in the AI world, especially in the beginning, where there's a lot of money being spent in here. And in my opinion, a lot of these products, going back to our pricing conversation, are going to zero. Where you have these, yeah, whether it's chatbots or whatever, like there's once the model has been trained in that example, once you have the
Right.
weights, it is the marginal cost is zero. I guess there's a large cost in developing those weights, but after that, it's zero. And you're going to start getting, there's nothing to stop, the Chinese competitor or someone else from doing it much cheaper and then charging nothing for it. And so, yeah, like I'm curious if how you're thinking about these dynamics. And you've already mentioned, yeah, we haven't seen much pricing power from these early experiments. But is it a fool's game to invest so much money in AI only to have your price go to zero?
Well, I mean, I think you're hitting on something that like growth, like people aren't yet finding growth with these, right? But they are finding efficiency. I still kind of come back to the fact that if you're not actually learning how to work with these products, like you're not going to make that step into actually building features that use this. And I do think like, we'll probably get past the chatbot phase, which feels like where it feels like we're in the chatbot age right now, and there needs to be something else where people actually attach this to the right business problem. I saw the same with machine learning, where people would attach machine learning to problems that were already solved. And you kind of have to find that problem for your business or your industry at least, that's unique enough that can drive growth from. And I don't think many organizations have found that right yet.
What do you think some of these fun problems will be that are going to be very differentiated? if not chatbots?
I don't actually know. I'm excited to see. I think it would be an interesting position to be in these companies, sort of having the expertise to look at those problems and explore. This is kind of takes me back to my time at the Times, but like once you understand the business, you can kind of point out where these applications might be most effective. And that's some of the most fun work, I think, for data teams is actually saying we can solve this problem in a different way. But I don't think I've got a great answer for you on what the age is after we get through the chatbot era.
Yeah, I've been asking ChatGPT that question on a regular basis. I feel like it could use some recursion here. It's like, hey, AI, help me figure out what the next AI thing is gonna be. So at some point,
Yeah.
it's gonna give me the answer. What have you seen from a geographic distribution? You're from Australia. Are there any cool AI companies coming out of Australia?
I don't actually know if there's any coming out of Australia at the moment. I have a lot of exposure to the ones that are ramping up in the US. I'm part of a group called Invest in Data. So we see a lot of US companies there. Um, and some companies coming out of Israel. I'd be interested for more of a global take on that. Have talked to a bunch of companies coming out of France and Italy that are like interesting startups in this space.
Yeah. Yeah, I've been thinking about that. Yeah, the geopolitical side of this as well, because it's through technology, these smaller countries can have an outsized impact. Whenever there's a new technology, we have seen, like, even with blockchain and Bitcoin, we've seen a bunch of South American countries that are jumping on board and trying to have that be the thing that differentiates them. This similar trend is happening within AI because you can have these types of companies operating from anywhere that can end up becoming massive. And I was just even looking at you guys, right, as a company. You guys, if I'm correct, you guys are like unicorn status, and you only started what in like 2019, right? It's
Yeah.
phenomenal work in such a short amount of time,
Yeah, and I mean that's testament to the great team we have there at Monte Carlo and really just finding a category that needed to be solved. I was a customer of Monte Carlo before I came to Monte Carlo, so it was a problem that I saw as pervasive in my data career. But yeah, it's kind of it's an interesting time to be in the space.
for sure. Where do you go to meditate on a problem now? Like when you were a kid, that was the grocery store. Do you find that kind of space to think?
I play soccer, so I sometime I'm not sure I get much meditation done there, but I maybe take out some aggression on the soccer field. And then I'm training to run a half marathon at the moment, and I find running is probably my best meditation on ideas. I can kind of put an idea in the back of my head and then go for a long run, and hopefully during that run I get a bit of a brainwave.
I love it. I love it. Well, yeah, that's his. The things that us humans are gonna have to go back to. It's we've been running for millennia, and that's still gonna be something we can do in the AI age. So, well, Shane, it was a pleasure learning about your life and career and getting to touch on these topics that are becoming very prominent. Thank you so much for joining me.
Yeah, I've enjoyed it. Thanks so much, Mate.